We're going to look at this video at an inclined plane question. It says, below shows two boxes P and Q connected by a light inextensible string which passes over a smooth fixed pulley at B. AB is rough and inclined at 30 degrees to the horizontal. P has a mass 8 kilograms and the coefficient of friction between P and the slope is 0.7. I'll just write that in. So your mu is equal to 0.7. And box Q has a mass of 3 kilograms and hangs freely. Okay, so I'm going to add a couple of things into my diagram here. So Q is 3 kilograms, so downwards you're going to have 3 Newtons. Upwards you're going to have a tension. You're also going to have a tension going this way. And also you've got the weight of Q. So P was 8 kilograms, so that's 8 Newtons. And I'll just do a normal reaction here, so going perpendicular to your plane, and this angle in here is going to be 30 degrees as well. So that's what you have got. Okay, it says it hangs freely, they're released from rest, and the string remains taut throughout the motion. So it says find the magnitude of the frictional force between plane P and Q. So, and find the acceleration of P. So it must be accelerating as well. So when we read on down the question, it's going to be accelerating downwards, obviously, this way, and downwards, but parallel to your slope here. So double-headed arrow for acceleration. And I always, now it doesn't matter in this one, but it's moving in that direction, moving to the right and moving down. But even if, and it's accelerating, but even if it was decelerating, I would put the arrow in the direction that it's moving, and then your acceleration would work out to be a negative. So that's just my way of doing it. Okay, we've also got something I've missed out on my thing. Because there's movement, you're going to have a frictional force going this way, which is going to be, and friction, because it's moving, it's acting at maximum. So friction is acting at mu r. So there's your diagram. So I've cheated a wee bit and used their diagram to save me drawing it out. So that's, I've drawn everything I can do on this thing. And then, so that was part one. Part two says find the magnitude of the frictional force between P and the plane AB. So basically we want to find mu r. So if we, I'll do this at the side here that we can still see this. So you can see, I'm going to look at P. So just say at P for part two here. First of all, I'm going to say resolve perpendicular to your plane. And I'm going to get r is equal to, and that's going to be 8g cos 30. So let's just do that on our calculators here. Bear with me, I've got to change my calculator into degrees mode. Make sure your calculator's in the correct mode. So 8 times 9.8 times cos of 30. And that works out to be 60. I'll say my r is equal to 67.89639 ... Okay, so that's what it is equal to. And then my friction then is equal to mu r. So in this case, that's going to be 0.7 times 67.89639. So I'm just using my calculator. I've already got that up in my calculator scale is 67.89 and so on. And just do times 0.7. And what I got was 47.52747 newtons. I'll give that to 2 decimal places. 47.53 newtons to 2 dPs. I will use this one if I need to use this, when I need to use this in the next question as well. Okay, last part of the question asks me this. It says find the acceleration of P. So that's the acceleration of P is acceleration of the whole thing, the whole system. So for part two, I'm going to look at the whole system just. So part three, sorry, I'm going to say the whole system. Whole system, and I'm going to use F equals ma. Now, if you do the whole system, the advantage of using a whole system is you can forget about the t's, because I'm going to write this out, and I'm going to write it out as I actually would write it out properly. So if I was doing this out, what I would do, my F, so my pulling force that's getting it going, is this force here. Okay, and then I've got a T going against that, so it'll be a minus T. I've also got a T going for it, so that's a plus T. Then I've got my 0.7 R going against it, and also going for it is 8G sine 30. So it's going to be acting down this way. So the 8G sine 30 is going to be acting this way. So you could write it in like this. You could write it as 3G minus T plus T, and then minus our 0.7 R, which we've just worked out is 47.52747, and also plus you have your 8G sine 30, and that equals my total mass, which is 3 plus 8, which is going to be then 11 times my acceleration. Now, if I'm quite honest, folks, I don't ever write it that way. I wouldn't ever bother putting this in, so I would just leave those out from the very word go. So let's just look at what we've got. The 3G was this force here, which is obviously getting the thing going. And then going against that, well, I've got my T and then a T going forward. We'll forget about them. You've also got your frictional force, which is this force up here. And then going forward as well is the component of the weight going down the slope. So this is 8G. We don't have the angle. That's why we use sine 30. Okay, we're just going to put that all into our calculator. Okay, so if I put that in, I have my 3G first of all, and then minus that other thing there, and then plusing my 8 times the 9.8 times sine of 30. And when I worked that out, I got 21, I'll do 5 dPs again, 21.07253 is equal to 11A, and then divide across by your 11. So just do that, answer in your calculator, divide it by 11. And when I did that, I got 1.92 meters per second squared. And again, I've gone to 2 decimal places. Okay,